Hello, I'm MeshCentral, and in this video we're going to talk about Intel AMT system defense. So Intel Active Management Technology, Intel AMT, has a lot of features that are built underneath the operating system right into the platform. And one of them is Intel System Defense. And so I want to take a look at this today and how it works. So I'm going to first switch to a few slides, and then we'll go into MeshCommnader to demonstrate this. So first, just a quick overview of what's going on here. At a high level, we have your platform with your operating system at the top, and it's talking through a network interface to the network. And so this could be wired or wireless. And so what happens is that as packets flow up and down the network interface, they obviously get processed and sent to the operating system if they're inbound, and the operating system sends data back to the network interface. But if you have Intel Active Management Technology, there's a set of filters that are placed in hardware on the wired interface. And what happens is that when certain packets come in, if they match those filters, then the packets are diverted over to the management engine. And those packets roughly are TCP packets on port 16992 to 16995. Those are packets that normally would go to the OS, but they get intercepted and sent to this other small operating system called the management engine inside the chipset for processing. So it's interesting because you have these packets that the OS can never get. Like you can listen to port 16992 on a remote interface here. And if you try to connect, the connection will be diverted. It won't go to the OS. So that's the basics of Intel AMT and how out-of-band management work. Well, it turns out that in addition to these filters that divert packets to Intel AMT, you can also put your own custom filters on top of the existing ones. And you can use that to perform traffic management and monitoring on data that goes in from the NIC or outbound from the OS out. So this happens for wired interfaces. This happens in hardware on the NIC. For wireless, this happens in the driver. So the Intel wireless driver will have these filters enabled, and when packets are sent, instead of doing it in hardware, it's done in the driver. But it's still controlled by by Intel AMT. Okay. So why would you do this? Well, if you want to monitor a platform independently of the OS, that's a good place to start. For example, maybe you have an ATM machine, you have some device that's security sensitive, and what you want is to filter out all packets, and so that the OS can only talk to certain IP addresses on the network. So for example, you have an ATM machine and you don't want the OS, regardless of what happens in the OS, you want the OS to only talk to a certain range of IP addresses. Well, you can do that with Intel System Defense. You can also monitor like how many packets are received on port 80 or port 443, by putting filters there. And you can also rate throttle packets going outbound. You can say, you can't have more than a certain amount of packets that match this port or these IP addresses, and then for every second you can't send more than a certain amount. So that's roughly what you can do. And because this happens below the operating system layer, there's nothing the OS can do. And so it's like a hardware firewall. And also, it can be used as an outbound firewall to block packets going out. Okay, So if you're going to set this up, you can use MeshCommnader or MeshCentral or other tools. I'm going to use MeshCommnader for this video, but MeshCommnader is also embedded inside MeshCentral, so you can use that too. And what you're going to do is you're going to set up a system defense policy inside Intel AMT. A system defense policy has 0 to, I think, 16 filters. And so you can have up to 16 filters, and then you have a default action for that policy. So what will happen is that as packets come in or go out, each packet will be run against the filters of the active policy. There can only be one active policy at any given time for a network interface. So each packet will be matched against the filters. If a filter matches that packet, then the action for that filter is taken, and that's it. If none of the filters match, then the default action for that policy will be taken. And so what are the actions you can take? Well, you can allow a packet to go through. You can drop the packet, so just discard it, and you can rate limit the packets. So you can say, I allow a certain amount of packets per a certain amount of time. And so those are the three options you have. And in addition to that, you have the additional option to count the packet either being rate throttled, dropped, or allowed. So you can enable the count feature. And so another thing I want to mention is that this happens at full Ethernet speed. So it's not like the packet is being sent to the management engine. It's not like you receive a packet on the gigabit adapter, it's sent to the management engine, then sent back, and then goes to the OS. This is the gigabit Ethernet adapter has registers that are programmed with the filters, and so at very high speed, the packets, just the header of the packets are compared against the registers, and if anything matches, then the action is applied. But that's it. It's very, very simple. In fact, the filters resemble a lot what you would find in a network switch, a typical network switch or a network router. So you have those same filters kind of trying to find matches and then performing actions like routing. But here, we're using the same circuitry, but we're doing it on a client device. Okay, so hopefully that's clear. I am now going to switch over to MeshCommnader. So I'm going to go ahead and connect to one of my machines here. And as I connect to this machine, I want to point out that the machine is right next to me. And it is going to be the AMT machine on the lower right. So let's see. Right. I'm going to move the window here. So this is the AMT machine. And on the top, this is the console. So this is the management software. So what we're going to do is play around a little bit with the security system defense. So I'm going to go back here, and you're going to go in the system defense tab right there. And currently the wired policy is none, so there's no policy active on the wired network interface. You can define multiple policies and multiple filters. And what you do is you define your filters, one or many. I have one right here. And then you can define policies that take those filters and use some of them and order them the way you want. And then you can, once you have defined one or many policies, you can have one active at any given time. So let's start by doing a super simple policy, add policy, and I'm going to call it count drop all. So this is a policy that's very simple. It has no filters, and it's only going to drop and count everything that is on the transmit and on the receive. So it's a policy with no filter and just a default action. Drop all the packets, send or receive, and that's it. So I'm going to say OK. So I have my count drop all policy, and you can, when you click on it, you'll see the name and you'll see the default action of that policy, drop and count for both send and receive. Okay, now as soon as I create the policy, nothing has happened yet. The traffic is not being dropped, and that's because the policy is not active. So before I activate the policy, what I'm going to do is switch over to the other computer, and I'm just going to ping, let's see, I'm going to launch a little ping here stream to my home router, and so it's going along and pinging, and as soon as I'm going to activate the policy, and so to activate the policy, what you do is you click on the wired interface, you select the policy you want, and as soon as I hit OK here, it's going to activate it. So I'm going to switch back to dual view and click OK on the management policy, on the management console, and you will see that now the pings are stopped completely. It's saying timeout now. And the other thing you'll notice is that I'll go back to the management console. You'll see that MeshCommnader is polling occasionally and seeing what packets are being transmitted and received. And so far I have 35 transmit, 145 received, and it's going up at every polling interval of MeshCommnader here. So the platform would have normally received all these packets, but of course is being blocked. And another thing I can do, I'll switch back to the AMT machine. And yeah, you can see destination unreachable here. It's really stuck. If I open a browser, I can't browse anything. So I can open Firefox here, try to go to YouTube, and you'll see it just fails. And so there's really nothing you can do at this point on this machine. It's basically locked out of the network. Okay, so now I'm going to go back to my management console. And actually what we'll do is we'll just select none here as the policy for this wired NIC. And I'm going to, as soon as I say none and I click OK, you'll see the ping start again. So I drop, there you go, none, and you can see the pings have started up once more. Okay, now of course the thing is that my counters have stopped because I'm not counting anymore, so these counters don't work anymore. So if I hit refresh, no more counters. So what I want to do now is create a policy that just counts packets. That's all it does. So I'm going to create a new policy. I'm going to call it count all, and I'm just going to allow and count all of the packets and still no filters. And I'm going to say OK. So now I have a second policy called count all, and I'm just going to activate it. Boom. And now what we're going to see is MeshCommnader is going to poll the the counters for the default action, and it will say how many packets are sent and received. And if we go back to our AMT device, the pinging should be working fine. In fact, I can't see it clearly here, but I'll just restart it. You can see the pinging was working, and I can go on Hacker News, and that's working also. Excellent. Perfect. So, good. Now, let's suppose I want to only block ICMP traffic. I'm just going to do like a little more complicated filter. I'm not going to do super complicated stuff, but I'll get you started if you want to do more complicated things. So here I'm going to keep the count all. You're going to see the packet numbers go up. And eventually one thing you could do is pull this and graph it and display a nice little graph of how many packets are being sent and received on each platform in hardware. That would kind of be cool. Okay, so what I want to do now is I want to have a new policy that counts everything but drops only ICMP packets and nothing else. So I want to just drop that. So I'm going to create a new filter, and I'm going to create a filter just to drop ICMP. So I'm going to call it drop ICMP, and I'm going to put it IPv4. Now the match. I want to drop outbound. So I want every packet, that ping packet going outbound, I want it dropped. So here I'm going to say drop and count. You could also do rate limit. In that case, you select how many packets per second you want to allow. But I'm just going to do drop all and count it. And you also, the event log here, if you say event on match, the first time, once you apply this policy, the first time that filter is actually hit, it will put an event in the event log of AMT. And that could cause a event to be sent to the management console if you configured it with the subscriptions here. So what you could do is put a set of filters that you never expect anybody to match. But as soon as one of those filters matches, then you would get an event to your management console, and you would see, aha, some computer has matched that event. Now, once the event is fired, you'll need to undo and redo the policy to get the event fired again. But that's how that works. Okay, so I want ICMP. Now, the thing is, there's something called matching rules here, and I am going to go into MeshCommnader.com. MeshCommnader.com. Let's see here. I'm going to bring that website. And if you open it up a little bit, you'll see there's a MeshCommnader section, and there's something called defense rules. And this kind of explains to you what the matching rules are here. Now, in the future, we could have a better user interface, but basically this tells you that you can match a protocol ID, a destination address, a destination mask. There's also ports, and let's see, right here, destination port start and end. So you can also define a range of ports you want to match against. But anyway, what I'm going to do, and the TCP protocol is 6, UDP protocol is 17. The ICMP protocol is number 1. So what I'm going to do is just say protocol ID 1. So if it's an IPv4 packet with protocol ID 1 that's outbound, drop and count this packet and don't event it. And yeah, don't put it in the event log. So I'm going to say OK. So now I have this drop ICMP filter. Now what I want to do is create a policy that uses that filter. So I'm going to add a new thing called drop ICMP, allow other, let's see. You have a limited number of names, but just drop ICMP only. Let's just call it like that. So that's my policy. And I want to count, allow and count all the other traffic, so that everything else just is allowed. And then for the filter, I'm going to select my drop ICMP filter and say OK. And you have the filter right there. If you have 2 filters, you just make sure that you put them in the right order, because they're going to be matched, top to bottom. So I'm going to just have this drop ICMP one here. Obviously, if you have multiple filters that don't kind of overlap, it's not a problem. But if you have filters that overlap in how they match packets, then the order is super important. Okay, so I have my filter, I have my default action if none of the filters are matched, and that's it. I'm going to say OK. And so I have this new policy, the drop ICMP only policy, has 1 filter. You can see the name, the default, the filter. There we go. Okay, now to make sure this works, I'm gonna select the drop ICMP only. I'm gonna close this. And so before I click OK here, I am going to switch back to my AMT machine. And so right now, this AMT machine is, I can ping, and also I can browse the internet. So if I hit reload on Hacker News, it's working. So now I'm gonna, on the top here, I'm gonna enable my policy. Boom, I'm on drop ICMP only. And then you can see the ICMP is starting to fail. But if I hit refresh on Hacker News, it is totally working. If I go to DuckDuckGo, enter, boom, it's still working. And so then what you can see on the console is you can see the counters here. The top one says that it drops 7 packets. And then you can see the transmit and receive packet count. So now what's interesting is you can see all the counters for packets being sent and received and how many ICMP packets you've dropped. And so far I've dropped 10 here. So yeah, that's really good. You can do this for IP address ranges, port ranges, inbound and outbound. So for example, you may want to have a policy that says none of your computers in your corporate environment can be HTTP servers. So you want to block inbound port 80 and 443 for all the computers. And then you may want to check how many times the computers have tried to access port 80 and 443 on those computers, so you can have counters for that. Anyway, there's a lot of stuff you can do with this, but because there's a lot of flexibility in how you can set up the filters and how you can basically stack the filters together. But hopefully this was helpful to kind of give you an introduction to how this works. So this was Intel AMT System Defense. Hopefully that was helpful. Take care. Thanks.